For decades, the story of human evolution seemed relatively straightforward. We pictured a neat line, a march of progress from stooped ape-like creatures to upright, tool-wielding humans. It was a simple, elegant narrative. But then, in 1972, on the shores of what was then called Lake Rudolf in Kenya, a discovery was made that would shatter this tidy picture forever. A team led by the renowned paleoanthropologist Richard Leakey unearthed a skull, designated KNMER 1470. This wasn't just another fossil. It was a puzzle piece that didn't fit. It was the face of Homo Rudolfensis, and it was about to redraw the map of our own origins. So, what was so special about this skull? At first glance, it presented a baffling mix of features. Dated to around 1.9 million years ago, it was clearly old. But its brain case was surprisingly large, estimated at around 775 cubic centimeters. To put that in perspective, that's significantly larger than the brains of its contemporaries, like Homo habilis, and much larger than the earlier Australopithecines. A bigger brain suggests more advanced cognitive abilities, a crucial step on the path to becoming human. But the real shocker was the face. Unlike the prognathic or jutting faces of other early hominins, the face of KNMER 470 was remarkably flat and broad. This was a feature we typically associated with much later, more modern humans. It was a modern face on an ancient skull. This combination of a large brain and a flat face was a direct challenge to the linear model of evolution. The old idea was that one species smoothly transitioned into the next, each one a little more advanced than the last. Homo habilis, the handyman, was supposed to be the sole ancestor of later Homo species. But here was Homo Rudolfensis, living at the same time as habilis, yet possessing a unique, and in some ways more modern, set of traits. It was like finding two different car models from the same year, but with completely different engine designs. It meant that our family tree wasn't a single trunk. It was a bushy, branching shrub with multiple experiments in being human happening all at once. The discovery forced scientists to ask some fundamental questions. Was Homo Rudolfensis a direct ancestor of ours? Was it a male version of Homo habilis, exhibiting extreme sexual dimorphism? Or was it a completely separate evolutionary branch, a cousin species that eventually died out? The debate raged for years. Initially, some tried to lump it in with Homo habilis, but the differences were too significant. The shape of the jaw, the size of the molars, and that distinctive flat face all pointed to a different species. The name Homo Rudolfensis was eventually proposed and accepted, acknowledging its unique place in the hominin lineup. This wasn't just about naming a new species. It was about recognizing the incredible diversity of early human life. Imagine the African savanna nearly 2 million years ago. It wasn't home to just one type of early human. Instead, you might have had groups of Homo habilis with their smaller brains and more ape-like faces, living alongside groups of Homo Rudolfensis with their larger brains and flatter features. You might have even had the last of the robust Australopithecines, Paranthropus boisei, with their massive jaws for chewing tough plants, sharing the same landscape. It was a world teeming with different hominin species, each adapting to the environment in its own unique way. The idea of a single missing link was replaced by a more complex and fascinating reality of multiple lineages coexisting and competing. So what was life like for Homo Rudolfensis? The fossil record gives us clues. While we haven't found any specific tools directly and exclusively associated with them, it's almost certain they were tool makers, like their contemporary Homo habilis. The Odoan tool industry's simple stone choppers and flakes was widespread at the time. These tools would have been essential for survival, allowing them to butcher animal carcasses, break open bones for nutritious marrow, and process tough plant materials. Their larger brains would have supported the complex planning and social cooperation needed for hunting or scavenging. However, it's also important to note what we haven't found. There's no evidence of symbolic behavior, no art, no burials, no ornaments. These hallmarks of modern human culture would appear much later in the archaeological record. So while Homo Rudolfensis was biologically taking steps toward modernity with its larger brain and unique facial structure, its behavior was likely still very different from our own. They were pioneers in a new way of being, but the full suite of what we consider human was still far in the future. The discovery of Homo Rudolfensis also had a profound impact on how we interpret the fossil record itself. It taught us to be wary of simple narratives and to expect complexity. Every new fossil has the potential to rewrite what we thought we knew. The story of KNMA1470 is a perfect example. It showed that evolution doesn't always proceed in a straight line. It experiments. It produces diverse forms and not all of them survive. Some branches, like Homo Rudolfensis, thrive for a time before disappearing from the fossil record, leaving behind tantalizing clues about what could have been. This concept of a bushy family tree is now central to paleoanthropology. We now know that Homo erectus, which appeared slightly later, also coexisted with other hominins. The story of our origins is not a relay race where one runner passes the baton to the next. It's more like a chaotic tournament with multiple teams on the field at once. Some get eliminated early, while others advance. Homo Rudolfensis was one of those fascinating teams that played a crucial role in the early rounds of the tournament of human evolution. Today, the skull KNMER 1470 sits in the National Museums of Kenya, a silent testament to a revolutionary moment in science. It's more than just an old bone. It's a symbol of scientific discovery and the ever-changing nature of knowledge. It reminds us that our past is far more intricate and surprising than we could have ever imagined. It forced us to abandon a simple, linear story and embrace a more complex, diverse, and ultimately more interesting account of how we came to be. Homo Rudolfensis may not have been our direct ancestor, but its discovery fundamentally changed our understanding of the path that our ancestors took. It proved that deep in our past, the world was home to more than one kind of human, and that the journey to becoming Homo sapiens was anything but a straight line. Have you ever wondered when our ancestors first started to think like us? Not just surviving, but truly thinking, planning, and creating. Today, we're diving deep into the past, nearly 2 million years ago, to meet a fascinating and somewhat mysterious member of our family tree, Homo Rudolfensis. This isn't just a story about old bones. It's the story of the very dawn of human cognition, the moment our journey towards becoming the thinkers and builders we are today truly began. So, who was Homo Rudolfensis? Discovered in Kenya, near Lake Turkana, previously known as Lake Rudolf, hence the name, this hominin lived around 1.9 million years ago. What makes them so special? Well, when scientists first examined the famous skull, KNM of 1470, they noticed something remarkable. Its brain case was significantly larger than that of its earlier Australopithecine relatives. We're talking about a cranial capacity of around 775 cubic centimeters. To put that in perspective, that's a big leap, suggesting a major expansion in brain size was underway. But a bigger brain isn't just about more space. It's about what you do with it. This increase in size points to a growth in neural complexity. More neurons, more connections, more processing power. This wasn't just a bigger engine, it was a more sophisticated one. This is where we see the first glimmers of the cognitive abilities that would come to define the genus Homo. Think of it as the brain's hardware getting a major upgrade, laying the groundwork for all the amazing software like language, art, and complex problem-solving that would develop much, much later. Now, a big brain needs a capable body to carry out its commands, and Homo Rudolfensis did not disappoint. When we look at their anatomy, particularly their hand bones, we see evidence of a precision grip. What does that mean? It means they could touch their thumb to their fingertips with precision and force. This might sound simple, but it's a game changer. This grip is the key to making and using sophisticated tools. While the first simple stone tools, the Odawan tradition, predate Homo Rudolfensis, their anatomy suggests they were not just using these tools, but were capable of refining them, of creating sharper edges and more specialized implements. This ability to craft tools represents a huge cognitive leap. It's not just about picking up a rock and smashing something. It's about looking at a piece of flint, visualizing a tool within it, and then executing a series of precise strikes to create it. This is what we call practical cognition. It's thinking in a very tangible, goal-oriented way. How do I get the marrow out of this bone? How can I make this rock sharp enough to cut through hide? This type of problem-solving is the foundation of all future technology. Before our ancestors could dream of smartphones, they first had to master the stone chopper, and Homo Rudolfensis was right there at the forefront of this revolution. Beyond their hands, their entire body plan tells a story of adaptation and intelligence. Fossil evidence suggests that Homo Rudolfensis, like other early members of our genus, was built for endurance locomotion. Their longer legs and changes in their pelvic structure indicate they were efficient long-distance walkers and runners. Why was this so important? In the open savanna environments of Pleistocene Africa, The ability to cover vast distances was a huge advantage. It allowed them to track migrating herds, scavenge for carcasses over a wide area, and escape predators. This wasn't just a physical adaptation. It was a cognitive one. Endurance running requires planning. You need to know where you're going, pace yourself, and anticipate the movements of other animals. It requires a mental map of your environment and the ability to remember where resources are located. This constant need to navigate and strategize across a large landscape would have been a powerful selective pressure, favoring individuals with better spatial awareness, memory, and foresight. It's the beginning of us not just living in our environment but actively thinking our way through it. So we have a bigger brain, hands capable of making tools, and a body built for long-distance travel. How did these all come together? This is where we see the crucial distinction between practical and symbolic cognition. Homo Rudolfensis was a master of the practical. Their cognition was grounded in the here and now, finding food, making tools, avoiding danger. This is the bedrock of intelligence. You have to be able to solve the immediate problems of survival before you can start pondering the meaning of the stars. There's no evidence that Homo Rudolfensis had art, religion, or complex language in the way we understand it. Their thinking was likely concrete, focused on tangible outcomes, but don't mistake practical for simple. The cognitive skills they were developing were incredibly sophisticated and laid the groundwork for everything that followed. The ability to plan a multi-step process, like tool manufacturing, is the precursor to planning a hunt or building a shelter. And this brings us to one of the most important developments: cooperation. While it's hard to find direct evidence of social behavior in the fossil record, the challenges of their environment strongly suggest that cooperation was key. Hunting or scavenging large animals is much more successful as a group. Defending against predators like saber-toothed cats is a team sport. Living this way requires a new level of social intelligence. You need to be able to understand the intentions of others, coordinate your actions, and share the rewards. This is where the foundations for things like planning, cooperation, and memory really start to solidify. Imagine a group of Homo Rudolfensis spotting vultures circling in the distance. They need to communicate this observation, perhaps with gestures and simple vocalizations. They need to coordinate their approach to the carcass, with some watching for predators while others quickly butcher the meat. And they need to remember where they found this resource and how to get back to their home base safely. Each of these actions relies on a growing suite of cognitive skills. Planning. We will go there, get the food, and come back. Cooperation. You watch. I'll cut. Memory. This is the spot where the gazelles cross the river. These aren't just isolated skills. They are an integrated system. The brain, the body, and the social group are all working together, creating a feedback loop where each new ability opens up new possibilities, which in turn drives the evolution of even greater intelligence. So, while Homo Rudolfensis may not have been having philosophical debates around the campfire, they were taking the first critical steps on the path that led to us. They were the pioneers of practical thought, the innovators who turned stone into technology, and the collaborators who learned that working together was the key to thriving. Their larger brains weren't just for show. They were problem-solving machines, driving a new way of life on the African savanna. They represent a pivotal moment in our evolution, the point where the cognitive Rubicon was crossed. The shift towards bigger brains, tool use, and a cooperative, wide-ranging lifestyle set the stage for all the amazing achievements of the human lineage. From the hand axe to the iPhone, from the first shared meal to our global civilization, the seeds of it all can be found in the minds and bodies of ancestors like Homo Rudolfensis. They show us that before we could reach for the stars, we first had to learn to think with our hands and plan with our feet. Imagine stepping back in time, about 2 million years ago, to the sprawling savannas of East Africa. This isn't just a scenic backdrop. It's a world teeming with both immense danger and incredible opportunity. This was the world of Homo Rudolfensis, one of our early ancestors. And understanding their environment is the key to understanding them. The East African Rift Valley back then was a dynamic mosaic of habitats. You had open grasslands, dense woodlands, and life-giving lakes and rivers. This environmental diversity meant a wide array of resources, but it also meant a staggering number of predators. Picture this. Giant hyenas, saber-toothed cats, and massive crocodiles were all part of the neighborhood. For a relatively small, slow-moving hominin like Homo Rudolfensis, just surviving the day was a monumental achievement. This constant threat, this ever-present predation pressure, was a powerful force of natural selection. It wasn't just about being strong or fast. It was about being smart and, most importantly, being social. An individual on their own was an easy meal, but a group? A group could watch each other's backs. They could create a perimeter of vigilance, with multiple sets of eyes and ears scanning the horizon for any sign of danger. This wasn't just a casual get-together, it was a life-or-death strategy. Cooperation became the ultimate survival tool. By sticking together, they dramatically increased their chances of getting another sunrise. This pressure to cooperate likely laid the very foundation for the complex social structures that would come to define the human lineage. So how did they eat? Hunting large game was incredibly risky, but the landscape was full of leftovers. When a saber-toothed cat brought down a massive buffalo, it couldn't eat the entire carcass. This is where Homo Rudolfensis saw an opportunity. They became expert scavengers. This wasn't a desperate last resort measure. It was a brilliant and efficient way to get high-quality nutrition. Think about it. Meat and bone marrow are packed with calories, fat, and protein-essential fuel for a growing brain. To get to these resources, they needed tools. The simple stone tools they crafted, what we call the Oldowan toolkit, were perfect for the job. They could use sharp flakes to slice through tough hide and cut off chunks of meat, and they could use heavier chopper stones to smash open long bones and access the nutrient-rich marrow inside. This act of scavenging wasn't just about food. It was a complex cognitive task. They had to understand predator behavior, know where to look for carcasses, and process the remains quickly and efficiently before other scavengers, like hyenas, showed up. It was a high-stakes race against time that rewarded intelligence and planning. This scavenging lifestyle also fostered another crucial human trait, the sharing of knowledge. Imagine a young Homo Rudolfensis learning from an elder. They would watch how to select the right kind of stone, how to strike it just right to produce a sharp flake, and where to look for the telltale signs of a recent kill, like circling vultures. This wasn't genetic programming. This was learning. This was the transfer of vital information from one generation to the next. This process of social learning is what we can call a protoculture. It's the beginning of a shared body of knowledge, skills, and behaviors that are passed down through observation and imitation rather than instinct. An experienced individual might lead the group to a water source during a dry spell or show others which plants were safe to eat. This knowledge was the group's collective memory, its survival guide, and it was just as important as any stone tool. Every successful scavenging trip, every predator avoided, reinforced these shared behaviors and strengthened the social bonds within the group. When you put all these pieces together, the environmental pressures, the need for cooperation, the ingenuity of scavenging, and the beginnings of culture, you see a powerful feedback loop. The challenging ecosystem of East Africa didn't just passively shape Homo Rudolfensis. It actively drove their evolution. The need to navigate a dangerous world incentivized group living. Group living created a social environment where complex communication and knowledge sharing could flourish. And the nutritional rewards from scavenging provided the energy needed to fuel a larger, more complex brain. This larger brain, in turn, allowed for better tool-making, more sophisticated social strategies, and an even greater capacity for learning and remembering. It was a virtuous cycle. The environment presented a problem, and Homo Rudolfensis solved it through social and cognitive innovation. In doing so, they not only survived, but they also set the stage for the incredible journey of human evolution that was to follow. Their story isn't just about ancient bones and stones. It's a testament to the power of ecology in shaping the very essence of who we are. It shows us that from the very beginning, our ancestors were not just surviving in their world, they were actively thinking, cooperating, and learning their way through it, turning challenges into opportunities. Ever seen those charts showing a neat, straight line of human evolution from a stooped-over ape to us? Well, get ready to tear that up, because the real story is a whole lot messier and way more interesting. And one of the biggest troublemakers in our family tree is a character named Homo Rudolfensis. It's a fossil that completely changed the way we think about our own origins. So, what is Homo Rudolfensis? The story starts back in 1972 at a place called Kubifora in Kenya, near Lake Turkana. A team led by the famous paleoanthropologist Richard Leakey found a skull. But this wasn't just any skull. It was fragmented into over 150 pieces, and it took the brilliant work of his wife, Meave Leakey, months of painstaking effort to put it back together. The result was something nobody expected. The skull, officially known as KNMF 1470, was a puzzle. It had a surprisingly large brain case, about 775 cubic centimeters. Now, to put that in perspective, that's significantly bigger than the brain of Australopithecus, the more ape-like hominins we thought were our direct ancestors at the time. A big brain is a key feature we associate with the genus Homo, our genus. So easy, right? It must be Homo. Well, not so fast. The face of this skull was incredibly long, wide, and flat. It was also very robust. These are features that look much more primitive, more like an Australopithecus. It didn't have the delicate features or the prominent brow ridge we see in other early Homo species like Homo habilis. So you have a modern-looking brain size paired with a more ancient-looking face. It was a mosaic of traits that simply didn't fit into the neat boxes scientists had created. This is where the great debate began, and it's a debate that's still raging today. Initially, some scientists thought KNMM or 1470 was just a large male Homo habilis, with the smaller Homo habilis skulls being the females. This idea of sexual dimorphism, where males and females of a species look very different, is common in primates, but the differences were just too extreme. It wasn't just about size. The whole shape, the entire architecture of the skull was different. So the new hypothesis was that this wasn't just a weird Homo habilis. This was a completely different species. In 1986, it was given its own name, Homo Rudolfensis, named after Lake Rudolf, the old colonial name for Lake Turkana where it was found. But giving it a name didn't solve the problem. It just created a new one. Where does it fit? Is it truly an early member of our genus Homo? Or is it perhaps a late-surviving, large-brained Australopithecus? Some scientists have even suggested creating a whole new genus for it, arguing it's too different from either group. The lines are so blurred that paleoanthropologists can look at the exact same bones and come to completely different conclusions. It's a perfect example of how science is a process, not a book of facts. It's a constant argument, a constant re-evaluation of evidence. The story gets even more complicated. For a long time, KNMMR 1470 was the only good example of Homo Rudolfensis. A species based on a single fossil is always a bit shaky. But then, in 2012, Meev Leakey's team announced the discovery of more fossils from the same area. They found a new face and two jawbones that dated to between 1.78 and 1.95 million years ago. And guess what? They matched the unique features of the original Rudolfensis skull perfectly. They had that same long, flat face. This was huge. It confirmed that Homo Rudolfensis was a real, distinct species. It wasn't just a one-off weirdo. It was a population, a lineage that existed for a significant amount of time. And more importantly, it proved something revolutionary about our past. It proved that around 2 million years ago, in this one small part of Africa, there wasn't just one line of early humans. There were at least 3 different types of hominins living side by side. You had the smaller-brained but tool-using Homo habilis. You had the robust and powerful Paranthropus boisei, with its massive jaws for chewing tough plants. And then you had Homo Rudolfensis, with its unique combination of a big brain and a powerful face. Imagine that world. It wasn't a lonely planet with just our ancestors wandering around. It was a diverse landscape, a bit like the African savanna today, but instead of different types of antelopes, there were different types of early humans. They were likely competing for the same resources, the same food, the same water sources, the same safe places to sleep. This completely shatters the old linear view of evolution. It wasn't a relay race where one species neatly passes the baton to the next. It was more like a giant, bushy tree with many branches growing at the same time. And for a long time, our branch, the one that eventually led to Homo sapiens, was just one among many. And it wasn't necessarily the most impressive one at the time. This leads to an even more profound idea. The coexistence of these different hominins suggests that evolution was running multiple experiments in what it means to be human. It was trying out different body plans, different diets, and most intriguingly, different types of brains. Think of it as parallel cognitive experiments. Was the key to success a bigger brain, like in Rudolfensis? Was it the ability to make and use tools, like in Habilis? Or was it specializing in a particular diet, like Paranthropus? For a very long time, there was no clear winner. Each of these lineages was successful in its own way for a while. Homo Rudolfensis, with its large brain, forces us to ask, what was it using that brain for? We often link a big brain with complex tool use, language, and culture. But the truth is, we don't have definitive proof of what Rudolfensis was capable of. The tools found from that time period, called Oldowan tools, are very simple choppers and flakes. We can't definitively say which species made them. Maybe they all did. Maybe only one of them did. The existence of Rudolfensis suggests that becoming human wasn't a single event, but a gradual process with many dead ends and sidetracks. Evolution wasn't aiming for us. We are not the inevitable peak of creation or the end point of evolution. We are the last survivors of a once very diverse family. If you could go back in time 2 million years ago, you wouldn't have bet on our lineage, the Homo erectus line, to be the one to survive. Maybe you'd have bet on the big-brained Rudolfensis. But they, along with Homo habilis and Paranthropus, eventually went extinct. They are all lost branches of our family tree. So, why did our lineage survive while others died out? Maybe our particular combination of traits, a reasonably large brain, a versatile body capable of long-distance running, and a flexible diet just happened to be the right toolkit for the changing environments of the Pleistocene. It might have been adaptability, not just raw brain power, that saw us through. Homo Rudolfensis remains an enigma, a ghost in our family tree. It reminds us that our story is not one of predestined greatness, but of chance, contingency, and competition. We are just one twig on a massive complex bush, and most of the other twigs have been pruned by extinction. We are not the goal of evolution. We are simply the ones who are still here. And understanding the messy reality of our past thanks to fossils like Homo Rudolfensis is far more humbling and far more fascinating than any simple, straight-line story. Have you ever wondered what truly makes us human? Is it our big brains, our complex tools, or our ability to create art and tell stories? For a long time, we thought the answer was simple. A single, straight line of evolution leading directly to us, Homo sapiens. But the story of our past is much more complicated, more like a tangled bush than a single straight trunk. And one of the most fascinating branches of that bush is a mysterious ancestor called Homo Rudolfensis. Today, we're diving deep into the world of this ancient hominin to uncover what its existence means for our own identity. Who was Homo Rudolfensis, and how does this nearly 2 million-year-old relative challenge our understanding of what it means to be human? Let's travel back in time to 1972 to the shores of Lake Turkana in Kenya, which was once known as Lake Rudolf. It was here that a team led by the famous paleoanthropologist Richard Leakey made a groundbreaking discovery, a skull. Catalogued as KNMR 1470, this skull was different. It had a surprisingly large brain case, much larger than other hominins from that period, like Homo habilis. But it also had a very broad flat face, which was quite primitive. This unique mix of features sparked one of the biggest debates in paleoanthropology. Was this just a male Homo habilis, or was it something entirely new? For decades, scientists argued back and forth. But as more fossils emerged, a consensus started to form. This wasn't just a variation. It was a distinct species. They named it Homo Rudolfensis, after the lake where it was found. Living around 1.9 million years ago, Homo Rudolfensis shared the African landscape with other early humans. This discovery was a game-changer. It proved that our evolutionary past wasn't a simple relay race, with one species passing the baton to the next. Instead, it was a dynamic environment where multiple human-like species coexisted, competed, and carved out their own niches. Homo Rudolfensis was not our direct ancestor, but a side branch on our family tree, a cousin who ultimately went extinct. So why is this ancient cousin so important for understanding ourselves today? It all starts with that big brain. The brain of Homo Rudolfensis was around 775 cubic centimeters. Now, that might not sound like much compared to our average of 1,400 cubic centimeters, but for its time it was huge. It was significantly larger than the brains of Australopithecines, and even on the high end for Homo habilis. This tells us something profound. The trend towards bigger brains, the very hallmark of our genus Homo, began much earlier and was more varied than we ever imagined. It wasn't a single event, but an evolutionary experiment that happened multiple times in different lineages. Homo Rudolfensis represents one of these early experiments in cognitive expansion. Their large brain suggests they were grappling with complex challenges and developing new mental skills long before Homo erectus, the ancestor we often credit with major cognitive leaps. What kinds of challenges could have driven this brain growth? To answer that, we need to look at the world Homo Rudolfensis lived in. The Africa of nearly 2 million years ago was a place of dramatic environmental change. The climate was fluctuating, forests were shrinking, and vast savannas were expanding. This wasn't an easy place to live. Food sources were scattered and unpredictable. To survive, you needed to be smart. This is where ecology and memory come into play. A larger brain could have supported a more sophisticated mental map of the environment. Imagine needing to remember where to find fruit trees that ripen at different times of the year, where the best water sources are during a dry season, or the migration patterns of animals you might scavenge. This wasn't just about remembering locations. It was about understanding rhythms and cycles in the natural world. This ability, known as ecological intelligence, would have been a massive survival advantage. A hominin with a better memory and planning ability could secure more reliable food and avoid danger more effectively. The pressure to navigate these complex changing landscapes could have been a powerful selective force, favoring individuals with larger, more capable brains. Homo Rudolfensis shows us that this crucial link between memory, environment, and brain size was a key theme in human evolution from its earliest stages. So we have this big-brained hominin successfully navigating a tough environment. But what does this mean for our definition of humanity? We often tie our identity to things like complex language, art, and symbolic thought. We look at cave paintings from 40,000 years ago and say, that's when we truly became human. But Homo Rudolfensis had none of that. There's no evidence they created art, performed rituals, or had anything like a modern language. Yet they were clearly doing something right. They were adapting, surviving, and thriving for hundreds of thousands of years. Their story forces us to rethink what the foundation of humanity really is. Perhaps the core of human identity isn't about symbolic culture, but something more fundamental: behavioral flexibility. This is the ability to adapt your behavior to new situations, to solve novel problems, and to learn from your environment. Homo Rudolfensis, with its large brain and success in a volatile world, was a master of this. They weren't just running on instinct. They were thinking, planning, and problem-solving. They likely used simple stone tools, much like their contemporary Homo habilis. But their larger brain might have allowed them to use those tools in more innovative ways, or to better plan their foraging trips. They were resourceful and adaptable. This suggests that the human way of being, this flexible problem-solving approach to life, is much older than we thought. It's not a recent invention of Homo sapiens. It's a deep legacy that has been part of our lineage for millions of years. The existence of Homo Rudolfensis beautifully illustrates this point. They represent a successful evolutionary path that relied on cognitive power and adaptability long before the dawn of what we typically call culture. They didn't need to be us to be successful. They were their own unique form of human, one that played a vital role in the grand experiment of our genus. Their evolutionary journey reminds us that there isn't one single way to be human. Throughout our history, there have been multiple species, each with its own unique combination of traits, each representing a different answer to the question of survival. Homo Rudolfensis was not a failed experiment just because their lineage eventually died out. Extinction is the norm in evolution, not the exception. Instead, their contribution was in being part of that diverse portfolio of early human species. This diversity was our lineage's greatest strength. When environments changed, having multiple types of hominins exploring different strategies, some with bigger bodies, some with bigger brains, some with different diets, increased the odds that at least one branch of the family tree would survive. Homo Rudolfensis was a key player in this story of resilience. They helped pave the way for later hominins, including our own direct ancestors. The evolutionary know-how developed by species like Rudolfensis, the neural pathways for better memory, the ability to make and use tools, the capacity for social cooperation didn't just disappear when they went extinct. These traits were part of the genetic and behavioral landscape from which later species, like Homo erectus, emerged. They were part of the foundation upon which our own intelligence was built. So, when we look at the skull of Homo Rudolfensis, we shouldn't see it as a strange, distant relative. We should see it as a reflection of a deeper truth about ourselves. Our humanity is not a fragile thing, built only on the recent achievements of civilization, art, and technology. It is a robust and ancient quality, forged in the savannas of Africa millions of years ago. Our identity is rooted in the cognitive flexibility of ancestors who learned to map their world, the resourcefulness of those who survived unpredictable change, and the diversity of a family tree that experimented with many different ways of being. Homo Rudolfensis may not have left behind any cave paintings or written epics, but their legacy is written in our very DNA, in the adaptable, problem-solving brains we use every single day. They remind us that the foundations of who we are, our intelligence, our adaptability, our resilience are far older and deeper than any city, any empire, or any single culture. We are the product of millions of years of evolution. A story filled with fascinating characters like Homo Rudolfensis, a cousin who helped shape the journey that ultimately led to us. Thanks for joining me on this deep dive into our ancient past. If you enjoyed this journey through human evolution, be sure to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next exploration. What other ancient relatives would you like to learn about? Let me know in the comments below. See you next time.